This is a video lesson for 4.4 where we are going to be factoring quadratics where a is not equal to 1. In the previous lesson we had seen examples of factoring where a was equal to 1. For example, if we had x squared plus 8x plus 10, we had to factor this by finding two numbers that when you multiplied them they would be equal to the constant c. So in this case it'd be equal to 10. And when you add them together, they'd be equal to b over here. So for example, or let me make this 16 to 16. So if we want to find two numbers that when you add them up equal 8, when you multiply them give you 16, that would be 4 and 4. 4 plus 4 is 8, and then 4 times 4 is 16. And then you could just plug those numbers into your brackets, and then that's how you would factor this type of equation here. And that works when your a is equal to 1. When there's no number in front, it means there's an implied 1. But sometimes we don't have that. Sometimes we have a situation like the one over here, where a is different from 1. In this case, a is equal to 3. Now, what you would normally do first is you try to find the greatest common factor, pull that out, and see if you could make it into a form where a is equal to 1, like we saw in the previous lesson. But sometimes that won't work either. So for example, here, there's no greatest common factor to take out. So what we need to do is use some technique, a new technique called decomposition. So again, the first step would be to look to see if there is a greatest common factor that you can take out, and that would sort of turn your quadratic relation expression into one where a is equal to 1. But we don't have that in this case. There's no greatest common factor that we can take out. So what we need to do is we need to find two numbers that'll give us a product that's equal to a times c. So in this case, a is again 3 and c is negative 10. So we need to find a product that gives us negative 30. Two numbers multiplied together gives you negative 30. And their sum, when you add them together, it's still going to be b, which is in this case negative 1. So the main difference here is that instead of the product being c, the product is a times c. So two numbers, when you add them up together, they give you, when you multiply them together, they give you negative 30. When you add them together, they give you negative 1. Those two numbers seem to be negative 6 and positive 5. Let's see if that's true. So negative 6 plus 5 give you negative 1. That works out. Negative 6 times 5 gives you negative 30. So the product works out, the sum works out, fantastic. So what we need to do now is we need to do the decomposition, which means we're going to split the middle value, the b value, into the two numbers that we came up with. So I'm going to start rewriting my expression over here. So I'm going to have 3x squared minus x minus 10. And what's going to happen is this value is going to split. So I'll show you doing that. That's the decomposition part. So we're going to have 3x squared and then one of the numbers I chose was negative 6, so negative 6x. The other number was plus 5x. And then minus 10. So I didn't really change the expression because this minus 6x plus 5x is still negative x. They're still equivalent expressions. But by putting it into this format here, it's going to help me to factor this more effectively. So what I want to do now is group the terms into two groups, which allows me to factor this quite specifically. So for example, if you look over here, these two groups have common factors I can take out, and that group has a common factor I can take out, and this group also has a common factor I can take out. I want you to notice that we also have at the end of doing this process, we always have 4 terms. Now, if I do my common factor, I'll show you that in just a minute. Let me just rewrite this here. So we're grouping this up here. 3x squared minus 6x plus 5x minus 10. Let's find the common factor for the first two over here. So 3x squared minus 6x, coefficient-wise, looks like it's going to be 3, and variable-wise, looks like it's going to be x to the power of 1. So 3x can be taken out. If you take 3x out of there, that gives you x minus 2. Over here, it looks like a common factor is just 5. You can't take out an x because the 10 doesn't have an x, so we're going to have 5 taken out. And when you do that, you get x because 5 divided by 5 is 1. 5x divided by 5 is just x. And then minus 10 divided by 5 is minus 2. So what I want you to notice now is that you've created a situation where we have a common factor shared between the 3x and the 5. We have this x minus 2 here. So we can now factor the x minus 2 out, which basically means we get x minus 2 and then 3x plus 5. So you know you're doing something right when these two brackets here are common, are the same, so that at the end your result is going to be something like this, where the two that are the same can be written once and the leftover numbers are written in the other bracket there. And then to verify, what you can do is you can expand to see if you get back to the same, the original expression you had in the standard form previously. So for example, I would do x times 3x gives me 3x squared, using FOIL of course. Then x times 5 gives me plus 5x. Minus 2 times 3x is minus 6x. And then minus 2 times 5 is negative 10. And then when you clean that up, you get 3x squared minus x minus 10. And that is how you would factor using the decomposition method if you don't have an a that's equal to 1, if your a is something different from 1, and if you can't find the greatest common factor to begin with. So that means that through this verification, we did the right steps over here. So now we're going to try a few other examples together to make sure we really grasp this concept well. We're going to try factoring using decomposition if required, and then we're going to verify each one to make sure that we're on the right path. So we have 4x squared minus 4x minus 5. It doesn't look like there's a common factor that I can take out of here to make my a 1. Right now we know my a is 4. That's the number in front of the x over here. So I know for sure I need to find a number that gives me a product that's going to be a times c. So 4 times negative 5, that's negative 20. So two numbers, when you multiply them, they give you negative 20. But when you add them up, they give you negative 8, which is b over here. Negative 8. So two numbers that might do that would be negative 10. Let's try that out. I might be wrong, but we'll try it out. Negative 10 times 2 gives you negative 20. That works. And then negative 10 plus 2 gives you negative 8. That works as well. So negative 10 and 2 are the numbers that we need. So we're going to proceed with our decomposition. So we have 4x squared minus 8x minus 5. That's going to be equal to 4x squared, and we're going to decompose our middle term into plus 2x minus 10x. So this negative 8 became plus 2 and minus 10. They're still equal to negative 8, so it doesn't really change what my expression is. So what I've done is I've created two groups, really. The first group is the 4x squared and the 2x, and the second group is the minus 10x minus 5. And they'll all have their own common factors, which I can take out in order to help me with the factoring here. So the 4x squared plus 2x, a good common factor there would be the 2x. And so if I take 2x out, that results in 2x plus 1. And a good common factor to take out from minus 10x minus 5 could be, well, minus 5. So I take out the minus 5, and I divide each term there by minus 5. So minus 10 divided by minus 10x divided by minus 5 is simply 2x. And then minus 5 divided by minus 5 is plus 1. So you'll notice now that we have our 2x plus 1 as those common bracket terms there. And so what we can do is we have 2x plus 1 factored out. And then in the other bracket will be what's left over. So we have 2x from the front over here, and then minus 5 over there. So we have 2x plus 1 and 2x minus 5. And to verify the work, we can expand to see if we get back to our original value. So we can do 2x plus 1, 2x minus 5. We can start doing our FOIL. So first terms here would be 4x squared. We can then do our outer terms there, so plus or minus 10x. We can do our inner terms here, plus 2x. We can do our last terms here, minus 5. We can clean this up. Again, make sure you align those equal signs there. We get 4x squared. Minus 10x plus 2x is minus 8x. And then minus 5. So we get back to the same standard form, which means that we factored correctly. We're going to start example 2, doing a similar process. We're going to try decomposition to see if it will work out. So again, we're looking for a greatest common factor. It doesn't look like it exists here. Our a is not equal to 1. It's actually equal to 10 in this case. So what that means is we need a product. We need to find two numbers that when you multiply them together give you a times c. So 10 times negative 3, which is negative 30. And when you add them together, their sum will be the b value here, which is 1. So you can try, if you try negative 6 times 5, that does give you negative 30. Okay, great. But you'll notice if you do negative 6 plus 5, that gives you negative 1. So that's wrong. So you know you made a mistake there if you did that. So let's try something different. Sometimes trial and error, you have to go through it. If you don't get it right first time, just go back, erase it, and retry it. We can try negative 5 times 6 instead. So let's switch our signs there. Negative 5 times positive 6 would give us negative 30. And then negative 5 plus 6 would give us 1. So negative 5 and 6, those are the numbers that we're going to go with. And so we're going to go with the process of decomposition. We have 10x squared plus x minus 3. And we're going to decompose that. We're going to decompose the middle term, the x term, using our two numbers there. So 10x squared, x will become minus 5x plus 6x. That's still equal to x minus 5 plus 6x. And then minus 3. And so what we've done is we've created these two groups over here where we can find greatest common factors from. In our first group, our greatest common factor looks like it's going to be the 5x. And so we can divide each term by 5x. So 10x squared divided by 5x is 2x. And then minus 5x divided by 5x is minus 1. and we're going to continue this in the next part of the video.